I'm Shane Moeykens, and I work in the Webb, New Hampshire office for Ansys. I'm recognizing that I'm standing between you and lunch, so I'll try to be brief here. This is a lighter weight presentation than much of the content today, and it's really focusing on just giving you an overview of how HPC and IT trends are impacting our software development processes. So for those that don't know Ansys, we're a software development company. We're entirely focused on engineering and simulation tools, CAE technology. Ansys is best known for the mechanical modeling, structural analysis space. That's the roots of the company, but some don't know that today Ansys is the largest CFD provider in the world through mergers with CFX and Fluent. And with Ansys, we're the #1 provider in the electromagnetic modeling space as well. Headquartered in Pittsburgh, about 2,500 employees, but still not really a huge company. So to highlight a few of the trends, just jumping into the topic, this slide really captures two of the most important things underway right now within our customer bases is the focus on product integrity and also the increasing product complexity. And this really just, I can synthesize this. This is saying doing more and doing more complex work, more and bigger type problems. So the more part of this, back in the 90s, I was in the HVAC industry, and it was common to apply CAE tools to run a few design points in the V&D stages, late in the product cycle, the development cycle. Whereas these days, you find CAE moving forward, doing multiple point designs or Six Sigma, DOE, etc. So do it earlier, do a lot more of it. Don't optimize to a single operating condition, but really hone the design, make sure it works across a wide range of conditions. Essentially apply virtual product development, make sure the design's going to work before you even build the first prototype. And on the complexity side, we're moving in the last decade from simplistic geometric representation to really throwing the CAE at full-scale industrial models. The full 3D CAD representation of an automobile, etc. And applying more robust physics. So in other words, higher fidelity design. A third trend that's worth noting, and this is one that I'm personally involved with at the company, is amplify engineering, and it's really harnessing CAE early in the design cycle by design staff, mainstream product development staff versus the expert analysts, which the more traditional users of CAE. And how does this manifest itself in the context of this conference? The second and the third bullet, I think, are highly relevant, perhaps even more so than the first. If you have hundreds or thousands of engineers at a major OEM touching the tools, do you want all this data, all these tools to be distributed throughout the entire company on desktops, or should there be centralization? Well, IT management's voicing their opinion that they need to centralize such that everyone's accessing the exact same software tools, accessing the same body of data, and essentially through the centralization facilitate collaboration. So let me just highlight this through one benchmark case that I was actually involved with. The initial work was done 18 to 24 months ago, and we call it the 50-50-50 study. And it really it was as simple as running 50 shape variations of a Volvo automobile, 50 million cell meshes, and the intent was to complete the entire scope of work within 50 hours of runtime. And I'll admit, when we started this project, we weren't sure that this was possible or not, at least with our software technology. So we jumped into the work with a distributed team. There were staff from Ansys from India, staff from Sweden working with this, some in the US. We applied our Workbench framework platform, which is equipped with DOE, Design Explorer, parametric type optimization tools. We brought all that to bear. And in the end, partnering with Intel, Intel was very closely involved with this work. We did find that we could, meet this performance spec. And I wasn't aware until reviewing this slide deck coming into the conference that the study had, at some point in the last 18 months, has been repeated with newer Intel architecture, and the speeds are even much better. So things continue to improve. It's a moving target. So what did we really learn here? Through the study, this was written up in a very nice SAE article and presented, 18 months back. But really what we were highlighting was there's huge benefit in automating the CAE workflow from beginning to end. And once that's done, you can effectively, throw HPC, large-scale hardware at it effectively, easily, and accuracy can be ensured by essentially applying high-fidelity models and looking at the real-world geometry, not simplifying it away. So let me shift a little bit from end-user trends to software development trends. This is a slide that was presented last year by an Ansys partner at one of our own user conferences, and I'm guessing most people here today are more familiar with these trends than I am, so I won't elaborate too much. But the shift over the last couple of decades from single-core to multi-core, and now we're jumping into this heterogeneous core with accelerator era. There's a whole lot of performance gains that are still out there, but we have to continue to tweak the hardware and modify the software to realize those gains. But this gentleman's point was, it's an imperative that the software firms continue to evolve their software infrastructure to really realize this. What was used 3 to 5 years back simply is inadequate for the hardware that's out in the market today. So I'll highlight this just through a few benchmark examples. This is Ansys Fluent 14.5. It's our current release of the Fluent CFD product. This is today the most heavily used CFD product in the world. It was in 2000 when I went to work for Fluent Inc. And through continued development and business success, it's maintained that leading pole position. But looking at the presentations this morning, where we're looking at a 1 million core count on DNS type problems, this is a very different type of approach. It's a general purpose code, implicit solver. It's equipped with physical models for every industry on Earth. This is a one-purpose tool used across many industries. So the ideal scaling is being realized out through about 4,000 cores here. But what was interesting to me, I was looking at a similar benchmark run with Ansys 14 and noticed that ideal scaling was only out to about 2,000 cores. So in a 12-month period, the development team basically doubled the range for ideal scaling, which I was a little bit surprised at, that they made that good of a jump in one release. And to highlight what we're doing right now with Ansys Fluent 15, this was an early preview release of 15. 15 won't be out until about the end of this year. And you see that, the performance gains continue to bear fruit. This is looking close to ideal scaling through about 8,000 cores, so about another doubling. Is this enough? Certainly not. We're being pushed by all of our major accounts all over the world to do, more and more of this. Many of our customers are interested in running on tens of thousands or hundreds of thousands of cores. We're already exploring that with some customers right now with 15, but this is data that I can share publicly. And very interesting is the work going on the GPU front as well. This slide captures work that we've done with NVIDIA, but it's also important to note that we're closely engaged with Intel. So, GPUs and the architecture of GPUs, I'm not an in-depth expert, but do understand that it really comes down to the numerics and the physics of what you're trying to solve and whether the GPU is going to be effective in terms of the overall solution. The numerics is the mechanical modeling on the FEA side. It's more of a sweet spot versus the performance of finite volume-based solvers. So we started with the mechanical products. But still, even in that case, it's taken us about 3 years to offer hybrid multi-GPU support. This is with Tesla GPUs, I believe. On the CFD side, it's more of an R&D effort today. The numerics are different, so it's a much harder problem to solve. One way to go about it is to break off pieces of the model and solve just that one portion on the GPU, like radiation heat transfer, scalar tracing. But here in the last year, through a collaboration with NVIDIA, we've developed a new algebraic multi-grid solver that does support GPU more effectively. And I'll show some benchmark data here in just a couple of slides. Here's benchmark data for the mechanical solver. So this is an 8-core machine with 1 and 2 GPUs. I think I should note first that this isn't a hypothetical problem. You know, this is a nonlinear static structural problem, 2.1 million degrees of freedom. And I would characterize this as a very common problem in terms of the day-to-day work that our customers, you know, are applying Ansys Mechanical to solve. So it's not an academic problem, it's a real-world problem. And what jumped out at me is how much performance gain was realized from the GPU. There's a 1.5 speed up with 1 GPU and with 2.4. The vertical axis here is jobs per day, so the higher the column, the better. On the CFD side, the left side, in my humble opinion, is not so relevant, but on the right, we're fully loading up a 12-core node with 1 GPU. There's about a 44% speed reduction in the solver time. This is with the code-developed new AMG solver that we built with NVIDIA. So we're only presenting the solver time, not the full solution time. The solver time is only 65%, but still, you know, this is looking very interesting. It's a good trend to continue with. So we're likely to be moving from R&D phases into full commercial release here fairly soon. And I'll broaden this a little bit and talk about more general IT trends and their impact on our development. You know, the first point we've just covered, but in terms of the centralized infrastructure, you know, trends towards centralized compute clusters, and along with those centralized data repositories, you know, these are very prevalent in our customer base today. It's interesting because I guess I'm getting old enough now to remember when large hardware was centralized, you know, sitting at the University of Maine in the 80s and accessing a Cray-WAN-P with the NASA facility, and then in the 90s, companies deploying group resources locally to the engineering teams, and that was the era train when I was working in industry. And now we're kind of going back to the 70s, so to speak. As the hardware gets bigger and bigger, it's less possible to distribute it everywhere, and companies need to consolidate down. And this picture kind of highlights that. It's a slide built by my boss, Barb Hutchins. It gets a lot of travel, but I think it's good, so I included it. But the red pens represent the centralized compute environment, and the black pens represent the distributed teams. And we've just touched base on some of this, but the key customer initiatives that are underway, the data center consolidation, you know, the virtual collaboration for these distributed teams all around the planet. With IP protection and leverage. Leverage is really implying data reuse. That all by itself is a very important trend today. Companies not wanting to rerun the same problem over and over and over, different teams, different years, but just archive that data and access it and apply it in the future. And virtual desktop initiatives, which, you know, most companies want to push CA into those initiatives as well. So what does this mean for Ansys? It means that we need to have adequate data management support and the mobility and remote access. These are key development initiatives that are just as large as the HPC scaling here in the last couple of years at Ansys. We're working on a new mobile web-hosted user environment right now, and it will offer graphical interaction with desktop environment such that people from mobile devices can tie into the Workbench environment and monitor their jobs, launch jobs post-process from really anywhere. I'm not quite sure of the release schedule for that work, but I'm guessing it'll start showing itself probably by the end of this year and, you know, be improved with staged release. So it's important to mention cloud, since pretty much every ISV, you know, in the US, not the world right now, is very much focused on cloud. It's very strong in the CAD/PLM sector and CA as well. So I'll give you a bit of an overview on how Ansys uses this. You know, it's not singular. Most people, when they think cloud, they think of jumping onto the Amazon cluster on the far right of the spectrum and buying a couple hours of processing time for whatever application. Well, historically, within our customer base, the focus is really much more on the left, and internal, you know, compute clusters behind the firewall of the company. That's historically been the most important area for us, and it will continue to be for many years, is my guess. But still, there's a lot of interest here more recently in this hosted cloud, which is shown in the brown color on this slide. And how are we approaching the spectrum of cloud? It's really through three different avenues. One's the software itself, where seamless remote access is key. Hardware, we as a company, we're going to stay a software company. We're not going to become a hardware company, buy hardware, and make hardware available. But we will basically provide this type of solution through partnering with key cloud providers. On the business side, as we push towards new cloud offerings in the hosted shared cloud area, our approach isn't to blow up the software licensing model that we have and use today with our customers, but rather add an on-demand model to complement what's already there. And the strategy of hosted cloud is primarily just to offer peak capacity overflow. Some companies don't have the IT infrastructure to build these centralized compute centers themselves, so this is of interest for them, but still others that do have that type of infrastructure still seek value or find value in having the overflow capacity, not having to buy and build everything internally. This slide just better articulates the strategy with our hosted shared cloud. This is a very hot topic this year for us. We're working with several enterprise cloud providers right now. The intent is to brand a solution under Ansys to formally certify it. There'll be a similar look and feel regardless of which hardware provider we're working with. So, if it's a company like GE or GM and they have engineers in Italy or South America or wherever, it doesn't matter which solution they jump onto, it's going to have the exact same look and feel in terms of the portal. So we're working with capable companies in terms of compute clusters, graphic servers, data security, very proven track records. I'm guessing the first one of these solutions will be announced in Q2 of this year, with likely several more before end of year. And, this is more of an internal comment, but we're working with our sales force right now to gear them up to make this available to our customer base, because it is a unique opportunity, a bit different than what most of our sales staff are used to providing. So just in summary, I'll wrap this up. In terms of the trends that hopefully these trends are keeping the Ansys Inc. development team up very late at night. The HPC scale-up underway at all of our large accounts. It's not just at national labs and in academia, but it's coming back to major industrial firms as well. And it's not just improving the algorithms themselves, but the necessity to parallelize the entire beginning and CAE workflow, from meshing, post-processing, I/O. All of these parts are relevant, so we're really reviewing every single line of code in our applications. And lastly, the IT environment and these trends that I just touched on that really link back to the amplification of engineering. Pushing CAE upstream of the design cycle and allowing mainstream design staff to use it. And it's all being leveraged. It's all being done by leveraging centralized compute clusters and data storage. So if we hit these targets properly, we'll have the right performance in our next-gen products. And I'm confident the development team's on the right track to do that. I'll be here this afternoon. We're late, so maybe we should just jump into lunch. But I'll be here in the afternoon, and I'd be very happy to talk with anyone here about collaboration opportunities. To tackle the large types of benchmark problems that I'm highlighting here in this slide deck. We're very happy to partner with government laboratories, academic institutions. I don't think we're doing much with the Stanford HPC Center these days, and we very much welcome the opportunity.